Okay, so sometimes the goals of restoration need to be modified. Um, Once you start doing restoration, sometimes it doesn't go the way you hoped it would. So you might find that complete removal of invasive species is not possible, or that you're having trouble removing all the contaminants, or climate change is affecting how easy it is to restore the site. And so this can mean that you have to change your goals. One thing that has come up uh, with invasive species and with climate change is the idea of novel ecosystems. And these are new ecosystems that have no historical analog. So that means that different groups of species are coming together to create ecosystems that don't represent an ecosystem that has ever occurred before. And we think this is going to be more and more common as we can't get rid of some invasive species and as climate change is causing some species to move and other species may not be moving. And so we may end up with these new ecosystems, and they may have different ecosystem functions as well. Next, I wanted to focus in on wetland restoration. It is a huge focus. And I mentioned before that there's this policy of no net loss. And that means that wetland restoration is required by law if a wetland is destroyed. Recently, large hurricanes have also been a major motivator, particularly Katrina. People are starting to understand better that coastal wetlands really protect people. And if we don't have those wetlands in place, then storm surge is going to be more of a problem for different communities, especially low elevation communities that are closer to the ocean. We see ecological damage and flooding from hurricanes in Louisiana. We had this happen in 2020. We've had it happen many, many times. But it's getting worse because we have fewer wetlands. And the Louisiana Coastal Wetlands Conservation and Restoration Task Force has really been working to reduce this trend and to rebuild our wetlands because they have these really important ecological functions for people. So this shows a diagram of wetland loss. So this picture shows the estimated extent of wetlands from 1839. This shows what it looked like by 1870. This is 1993, and this is the projection for 2020, but this picture is from a couple years ago. And so you can see the difference from 1839 to 2020. We've lost a ton of wetlands. In fact, Louisiana is a hotspot for loss of coastal wetlands. We think of this as primarily a climate change issue, and climate change is certainly a factor. But the bigger issue is how we've controlled the Mississippi River. The Mississippi River carries tons of sediment every year. And it historically, before we put in levees and locks and dams and straightened and dredged the Mississippi River, it would flood every year or every few years and deposit sediments, and that would build up these wetland soils over time. We've basically straightened and dredged out the Mississippi River so that it's better for transportation of large barges and things like that. And so all that sediment's being dumped into the deep parts of the Gulf of Mexico. So it's not being deposited on land. And so without that, as we have waves and storm surge, it eats away at these coastal wetlands. And there's nothing rebuilding them unless we do something about it. And so this shows where the land loss has occurred. And so the orange is the most land loss. And you can see it makes up a large proportion of our state. And this shows the picture of the master plan to protect and restore Louisiana's coast. So the idea was to spend $50 billion over 50 years on hurricane protection and coastal restoration, including 500-year protection for New Orleans. The idea being that we have these frequencies of different size storms, different size floods. 500-year protection for New Orleans is to make sure that flooding and breaching of the levees doesn't happen again. So they want a very small probability that the problems that were seen during Katrina for New Orleans happen again. So we see different things. There's places where they've improved levees, which are more mechanical solutions, but they have other places where there's a lot of restoration going on. And so their green areas are all marsh creation. And so you can see they've targeted different areas for creating new marshes. They are working on barrier island restoration, which also form a really important mitigator of storm surge and really protects the marshes in between that then hold back storm surge for different cities in these areas just outside of the marshes. There's areas where they've been working on shoreline protection, ridge restoration, but you can see there's a lot of work being done on restoration in our state. So how do you restore a wetland? So this shows some pictures. Basically, the first step is to build up the land. So if it's just water, you want to start where there is some land and then pull more sediments up to make it higher, increase the elevation of the site. And a lot of times they are dredging from the bottoms of lakes and pumping sediments up to these areas. They remove any degraded soil to expose hydric soils, which are better for wetland plants. And this has been successfully used near Houston. Then you add plants. And so this shows pictures of community members planting wetland plants. This is from a work with Texas A&M, and they brought students in to help plant these plants and help restore these wetland areas. So these satellite images of the same wetland, this shows 2008 here. You can see a lot of it is water, and this shows 2016 where they've restored the wetland. You can see all this area in here is new wetland that wasn't there before. And so they've been producing gains in marsh area. So the restoration has been effective. Now I'm going to move to restoring aquatic ecosystems a little more generally. So big problems with aquatic ecosystems that we've talked about are eutrophication. Does anybody remember what causes that? Hopefully you just said nutrients. And so too much nitrogen and phosphorus, usually from fertilizer or from sewage that's been treated. There's lots of nutrients in that. It can also occur from erosion, nutrients in soil mixing with the water. So point source pollution and non-point source pollution. The point source includes like pipes like from the sewage treatment plants. Non-point source pollution being things like fertilizers or livestock on broader areas. So how do we fix this? Point source is pretty easy. You just need to make sure the wastewater treatment plants are pulling nutrients out or try to make sure that nutrients isn't making it into water. You can spread those nutrients over land to help grow plants, things like that. Non-point source is much more difficult, but restoring vegetation around waterways is a big help because it helps to have some of the nutrients in runoff coming off the land percolate into the soil, but also the plants around the waterways may help take it up before it actually makes it into the water. A big example of where people have been working on this is the Chesapeake Bay, which is, basically where Baltimore is. There's all this pollution from residential and agriculture and industrial lands. that have caused major eutrophication. So you can see this picture. The green part is the obvious visual signal of eutrophication, where other parts of the water are bluish. This big green, that's a big algal bloom, and up to 40% of the Chesapeake Bay is eutrophic every year, so that's a pretty big problem. It's caused the harvests of fish and shellfish to decline, and that's kind of what the Chesapeake Bay is known for, is amazing seafood, but that industry has been going down majorly because of the really bad water quality that was in the Chesapeake Bay. Also unsafe for swimming. You can imagine in the summer when it's hot, it'd be really nice if people could go swimming and use the Chesapeake Bay as a recreational resource. But with this contamination, that's not always possible. This shows the blue crab harvest, which is a major industry, as I said, around the Chesapeake Bay. And this is in millions of pounds, and you can see from about 1945 to about the 90s, it was doing pretty well. But there was a major decline from the 90s into the early 2000s, where just the amount of blue crabs that could be harvested dramatically decreased. I saw the same thing with oysters, where in the 1950s and 60s, it was relatively high. There's some fluctuations. You can see it was relatively high in the 1970s as well, but in the 80s to about 2000, it's gone way, way down. And this shows the harvest from both Virginia and Maryland, and you can see this is not good for that industry at all. So this shows the 2007 Chesapeake Bay report card, and then the 2015 report card. And so you can see in 2007, there were major problems. They gave them health scales from F to an A, and you can see most of it's a D or a C. There was only a little tiny place up here, the Upper Western Shore, that was rated a B. And with some of the restoration efforts, they were able to increase this. And so almost every area has seen improvement. Where this whole mid-bay area was getting a D before, it's now getting a C. And the lower bay was getting a C, it's now getting a B. So not everything is massively improved, but you can see overall the Chesapeake Bay has been doing better. This shows some test plots. A lot of times when we're doing restoration, it's helpful to test different methods to see which one we want to continue to use so that we can make our restoration dollars be spent as wisely as possible. So we want to know what are the most effective ways to do restoration. What gives us the biggest bang for our buck? How fast can we restore it for the least amount of money? If we can do that, then we can potentially spend the same amount of money to restore more sites, or that money can be used for other conservation efforts, or potentially restore it more completely. We talked about partial versus complete restoration. If you have more money, if you know how to use it most effectively, that might allow you to take it farther in the future. So this is part of the Chesapeake Bay watershed. Here's a picture of the bay going through Virginia and into Maryland. And you can see where they spent their money. That picture was part of examples that they were working on for the Chesapeake Bay restoration. And you can see that most of the restoration dollars were spent on stream and river restoration. They did over 3,000 stream and river projects. They also focused on water treatment to make sure less nutrients from the cities were ending up in the water. They did some bank stabilization to make sure there was less erosion. And then they did a whole lot of other smaller projects to help improve the Chesapeake Bay. And all of these have added up and helped improve the health of the bay. So they started in the 1980s when I was a little kid, and they've spent $400 million. The biggest weakness is that they haven't really been monitoring most of those projects. So they spent the money, but they don't know how successful each bit of money is. And we talked about how important monitoring is. And most of these only monitored vegetation and not water quality. So it's hard to say which parts of the project made it the most successful, and like if they were to try and use this information to restore another bay, they don't really know which parts mattered the most. So that's kind of a weakness. Okay, so that's aquatic restoration. So I'll just stop the video here.